Today, our lesson is going to be on the VSEPR theory. And this has to do with the shapes of all those structures you have been drawing of the electron dot diagram. So you can pause the video and copy what I have underlined in red. So you want to copy VSEPR theory, and then this tells you what it stands for, which is valence shell electron pair repulsion theory. And so according to this theory, the repulsions between the electron pairs causes the shapes to adjust so that their valence electron pairs stay as far apart as possible. So there, when you're drawing your structures, your dot structures, you are not giving that 3D shape. Yours is a flat shape, 2D. So it's actually a 3D shape. So these are the shapes that you're responsible for: the linear, trigonal planar, bent, tetrahedral, and trigonal pyramidal, or you can say trigonal pyramid. And so here's what they would look like. And again, this is a flat model. This is not the 3D. And I'm going to show you 3D in just a minute on some of them. But this is linear, bent, trigonal planar, and then trigonal pyramidal or pyramid. And there's your tetrahedral. This is what a 3D would look like compared to the flat model. So how do we determine the shape? So I gave you a reference sheet in class. It's that little half sheet, and we're going to use that to figure out what our shapes are. But in order to do that, we got to make sure we understand some terms. So two things we're going to do. We're going to count the unshared pairs or the lone pairs for the central atom. So for example, here I've got a model right here. Trying to get it so you can see it better. So this is an electron dot structure, and we're going to first count how many unshared pairs we have. And remember, we're only counting it for the central atom. So if we look here, there's our one unshared pair. So we have one unshared pair. All right, then we're going to count the number of bonded atoms. So you're counting, you're going to look at your center atom in this case and count how many other atoms are bonded to phosphorus, and that's 3 bonded atoms. So now look at your reference sheet, and I'm going to pull it up right here. So we have one unshared pair. So here's our one, but we have 3 bonded atoms. So I'm going to find a 1 and a 3. So here's my 1 unshared pair, what we counted in the center, and this is the 3 bonded atoms. See the number of bonded atoms. So this is a trigonal pyramidal. So as you can see, this would be a trigonal pyramid. So that's how you would figure out the shapes. So let's do some other examples. So let's look at this one now. So again, these are flat models. So it's not giving you the appearance of the 3D. And I will show you the 3D models in class. So we look at our center atom. We do not have any unshared pairs or any lone pairs. We don't see 2 dots by themselves. What we do see is 4 atoms bonded to this carbon. So let's go look at your reference sheet. Find 4 bonded atoms, but we have to find 4 with 0 unshared pairs. and we do. This is an example of a tetrahedral. Also, you would have to write down what the bond angle is. So this one is between the carbons and or between the hydrogens is 109.5 degrees. So let's look at that. So from here to here is 109.5 degrees. So what you're going to be doing on your worksheet that you had to draw 15 Lewis dot structures, you're going to go back and then you're going to place beside each of your structures what the shape is and then what the bond angles. You're doing B and C. So let's do this one now. Here we have one unshared pair, and we have 1, 2, 3 bonded atoms. So now let's look at your reference sheet. Let me clear that. So we have 3 bonded atoms. So here's a 3, but this says 0 unshared, so that's not it. So keep going. Here's a 3 bonded atoms and 1 unshared pair. So this again is a trigonal pyramidal or trigonal pyramid. Oh, and then this is, now notice the difference. This is less than 190 or less than 109.5 degrees is your bond angle. So you would write that beside your structure. So I would write, so like if you're doing your worksheet, you would put um, the name of your shape or what the shape is, trigonal, and this was a trigonal pyramidal. And then you would also put the bond angle, and this would be less than 109.5. And this is what it would look like. The reason why, and this is a 3D model. So here's your lone pairs, your unshared pair right here. They're repelling with the electrons here and here. So that's why it's making this pyramid shape. So it's wanting to go away from these atoms. So we have, and then there's your bond angle. Okay, let's move on. So now let's look at this one. Again, we look at the center atom. We have one unshared pair. Now notice we have a double bond here and a single bond. And remember, when you have to draw something like that, remember you would have to draw both structures and put it in a bracket to represent that there's two different ways. We talked about that, resonance, today. So you have one unshared pair, and you still just have 1, 2 bonded atoms. Just because that's a double bond, you're not counting the lines, you're counting how many atoms are bonded to sulfur. So that's 1 and 2. So let's go back to our chart. So we have 1 unshared pair right here and 2 bonded atoms. So here it is, 2 bonded atoms or 1 unshared pair. So this is a bent shape, and then this is your angle. So that's what you would put. You would write bent on yours when you would on that worksheet, and then you would put the bond angle. All right, now let's look at this one. Notice there's no unshared pairs. So that means 0, of course. And then you're just counting how many atoms are bonded to this carbon. You're not going to count 1, 2, 3, 4 bonds. That's just the type of bond it is. It's a double bond. What you're counting is how many atoms are bonded to carbon, and that's 1 atom, 2 atoms. So we have 2 bonded atoms and 0 shared pairs. So we have 2 bonded, and that's 1. Here's 2 bonded, here's our 0 unshared pairs. So Our shape is linear, and it's 180. So you would write linear and then 180. So that's your B and your C. So this would have been A. And I'm just trying to give you an example what you will have eventually when you finish that worksheet that I had given you. All right, now let's look at water. So here we have, that's an unshared pair, and that's an unshared pair. So we have two of those. We have 1, 2 bonded to the oxygen. So we've got 2 and 2. Okay, so we look, here's 2 bonded atoms, but that's 1 unshared pair, so that doesn't work. So keep going until you find another 2. Here's your 2 bonded atoms, 2 unshared pairs or lone pairs. Your answer is bent. Notice we have 2 bents, but the bond angle is different. This bond angle is less than 109.4. So that's why you need to make sure you figure out the correct shape and then the correct angle. So this was bent and less than 109. All right, let's look at this one. And this one would have been a resonance because we have a double bond here. We also could have had it here, or we could have had it here. So we would have had to have drawn this 3 different times. All right, as you can see on sulfur, there's no unshared pairs, so that's 0. And sulfur is connected to 1, 2, 3 sulfurs. So let's go find 3 bonded atoms. So here's 3 bonded atoms, 0 unshared pairs. So that's what we want. There's our trigonal planar. And notice the bond angle is 120. So that's your trigonal planar. Oops, going backwards. All right. So this is trigonal planar, and it has no unshared pairs. So I wanted to show you the trigonal pyramid. Here we have 3 bonded atoms, but what's different is the unshared pairs. So for trigonal planar, there's no unshared pairs, whereas trigonal pyramid, there is. And you'll get to practice that. All right. So these are your 5. And your trigonal, your linear, your trigonal planar, your tetrahedral, your trigonal pyramidal, and then your bent. But I want to draw your attention to the trigonal planar and the pyramid. So, and I was just showing you that earlier. So notice the difference. This is the pyramid right here. This one is your pyramid. And then this is your planar. So notice the difference in the shape. This is up because you've got this unshared pair at the top that's pushing your other electrons down. It's repelling because light charges repel. And then this one does not have that unshared pair, so their bond angle is a little different. So you can see it's 120 for this one, and in this case 107 for this one. And I think that's it. Okay, so you should have your Lewis dot structures for 15 of them, and now go back through those 15, write down their what the shape they are by using your reference sheet. So use that reference sheet, and then by putting what their angle is. So you're putting the shape and their bond angle for each one.